Hello, welcome back to my channel. In today's video, we will discuss second internal questions. Let's get started. First question, apply steps of KDD to obtain applicable IPC section or BNS section from the following complaint. Give useful algorithms R or Python code, snip process for identifying applicable BNS sections. Answer. The steps of knowledge discovery in databases. The knowledge discovery in databases process involves systematically extracting useful information from large datasets. Here's how the steps can be applied to the given problem. Step first, selection. Objective, extract relevant data from the dataset. Example, complaint theft of my mobile phone by an unknown person at MG Road on 20 February 2023. The thief was wearing a black jacket and had a scare on his face. Focus on key features such as crime type, location, date, and description. Second step, pre-processing. Objective, clean and pre-process the textual data for analysis. Action, remove stop words, removing common words like off, at, was. Lowercase conversion, convert all text of lowercase for uniformity. Tokenization, break text into individual words or phrases. Example input theft of my mobile phone, output theft mobile phone. Stemming or lemmatization reduce words to their root form. Example stolen to steal. Third, transformation. Objective convert the text data into numerical or structured format for analysis. Techniques TF-IDF, term frequency inverse document frequency, measures the importance of each word in the context of the complaint. Vague of words represent text as a vector of word occurrences. Named entity recognition extracts specific entities such as MG road, location, date. Step 4, data mining. Objective, apply algorithms to identify the appropriate IPC or BNS section. Algorithm options, text classification, use name-based, support vector machine or logistic regression to classify the complaint. Deep learning models, transformers, use pre-trained models like BRT for advanced text classification, rule-based matching, map keywords, example theft, mobile, to IPC section, example section 378 for theft. Step 5, evaluation. Objective, assess the accuracy and relevance of the results. Use metrics like precision, recall, M1 score, and accuracy to evaluate the model. Example, precision, high if theft complaints are classified correctly. Recall, ensures all theft complaints are retrieved. Sixth, interpretation. Objective, map the classified complaint to IPC or BNS section. Example, mapping, extracted keywords, theft, mobile phone, mapped IPC section, section 378, theft. Explanation. IPC section 378 defines theft as taking someone's movable property dishonestly. Dishonestly. Then the second question, explain the decision tree process of data science and its various approaches to construct a decision tree from a database. How these structures and algorithms can be applied to effectively classify the complaint into appropriate IPC or BNS sections. Firstly, what is decision tree? A decision tree is a supervised machine learning algorithm used for classification and regression tasks. It represents decisions and their and their possible outcomes in the form of tree-like structures. Structure contain root node, internal nodes, and leaf nodes. Root node represent the entire data set or decision point. Internal nodes represent attributes or conditions to split the data. Leaf nodes represent the outcome, final classification or prediction. Steps to construct a decision tree. First, select the root node. Identify the attribute with the highest importance. Example, crime type for classifying complaints. Second, split the database. Partition the dataset into subset based on attribute values using splitting criteria like Gini index, information gain, or entropy. Third, repeat for subnodes. Apply the splitting process recursively to create child nodes until all data points belong to the same class or a stopping criterion is met. Example, max depth of the tree. Approaches to build a decision tree. First, ID3. First, ID3. Splits nodes based on information gain. Example, if the crime type provides the highest information gain, it will be selected as the root node. Second, CART, classification and regression trees. Uses the Gini index to determine splits. Second, works for both classification and regression tasks. Third, CHI, child, Chia square automatic interaction detection. Uses statistical tests like the Chia square test to determine splits. Random forest. Example of decision trees. Combines multiple decision trees for better accuracy and robustness. Decision tree in text classification for classifying complaints into IPC or BNS section. First, features. Extract meaningful attributes from the text using natural language processing. Example, features, keywords, crime type, date, location, target variable, IPC BNS section. For example, section 378 for theft, section 420 for fraud. Data pre-processed complaint. Example, theft of mobile phone, theft, mobile, phone. Now, another question. What metrics are appropriate for assessing the performance of algorithms using text mining? Give details of the matrices that evaluate the effectiveness and accuracy of text mining techniques. Matrices for accessing the text mining algorithms. Text mining algorithms are often used for tasks such as classification, clustering, sentiment analysis, and information retrieval. The effectiveness and accuracy of these algorithms can be assessed using the following metrics. First, accuracy measures the performance of correctly classified instance out of the total instance. Formula: number of correct predictions upon total predictions. Usage in text mining evaluates how well a classifier correctly predicts labels like topics, sentiments, or IPC or BNS section. Second, precision. Measure how many of the predicted positives instances are actually correct. Formula: e- precision equals to true positives plus false positive upon true positive plus true positive plus false positive. Precision equals to, sorry, precision equals to true positives plus false positive upon true positive. Uses in text mining useful in scenarios like spam detection where minimizing false positives is critical. Recall measures how many of the actual positive instances are correctly predicted. This is the formula of recall. Uses in text mining important for cases like crime report classification, where missing critical complaints, false negative could be costly. F1 score, a weighted average of precision and recall that balances the trade-off between the two. The formula of F1 score, 2 into precision into recall upon precision plus recall. Uses in text mining a key matrix when the data set is imbalanced. For example, more theft cases than fraud cases. Thank you for watching. Don't forget to like, subscribe, and share.